Today we're going to talk about slope. With slope, slope of a line is basically the steepness of a line. When we're talking about the steepness of a line, let's go back to what you think about as like a ski slope. A ski slope that's a bunny slope isn't very steep. You don't go very fast on it. It doesn't have a very steep slope. You can go then on Dead Man's Diamond Curve, which is a very, very steep slope, which you'd go very, very fast down. They form lines, and we're going to be able to calculate the steepness of a line. That's what slope is. So first thing we're going to talk about is the rate of change. What slope means is that they call it rise over run, because rise means my vertical change and run means my horizontal change. With my vertical change, we're also talking about my y-axis. So we also see where we have a change, that's what the little triangle means, of my y, which is up and down, over my change in my x, which is back and forth or horizontal. We also have abbreviation for slope, which we call m. With this, when we're calculating slope, it's always a fraction. It's always the fraction of rise over run. So we will keep it as a fraction. It will be improper, and that'll be okay. Never, 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 ever make it a decimal, because you have to see the change in the y over that change in the x. When we're talking about that, we can talk about the steepness or the direction of my slope. So I'm going to come down the side over here. Back to when we did scatter plots, we talked about a positive trend. It looked something like this. That is also called a positive slope. It looks the same as a trend in our scatter plot. With our direction as well, we could talk about a negative trend going down. That's the same thing as a negative slope. Then, as we saw in our notes the other day, we could have just a straight horizontal line, or we can have a straight vertical line. Now with this, 99% of our lines that we are going to graph are going to be diagonal. They're going to have an x and a y, and they're going to be diagonal. So very rarely do we have a horizontal or a vertical line. With slope, we have an equation. So with this equation, the equation for slope says y equals mx plus b. Now, in this equation, the x and the y refer back to the x and the y in our coordinate grid. So we just learned now that this m stands for what? Exactly, it means slope. So the slope of the line is always hiding in front of my x and being multiplied. This new piece is this b. The b is actually the y-intercept of my is where the graph intercepts my y-axis. That's what a y-intercept is. Why don't they call it y? Because I already have a y in my equation. So therefore they picked a different letter b to stand for y-intercept. So if I gave you this equation that says y equals 1/2 x minus 3, I could say to you, hey, what's my slope? You would say, my slope equals 1/2. I could say, hey, what's my y-intercept? Where is it going to cross my y-axis? You would say, hey, that's -3. I'm going to come down to ratio because I've already talked about this, and then we're going to talk about how to calculate slope. With the ratio right here, I've already told you that the ratio is the change in y over the change in x. It is always y over x. We also can say that it's rise over run, which also means vertical change over horizontal change. All right, so how do we calculate this fraction you keep telling us about? Well, the first way we're going to talk about it is in a table. In our table, what we're looking for here is we know that it's a change in our y over our change in our x. That's what slope is. So let's look here first how our y is changing. To go to -2 to -1, what did I do? I added 1. To go to -1 to 0, I added 1. To go from 0 to 1, I added 1. So that's a constant change within my y values to be 1. Then when I look over here on my x's, to go from -4 to -2, what did I do? Exactly, I added 2. To go to -2 to 0, what did I do? I added 2. To go from 0 to 2, exactly, I added 2. So my change in my x is 2. You have to realize that it's a constant change throughout my whole table for my x values or for my y values. So with that, I know that my slope is 1/2. Never a decimal, always a fraction. Because my change in my y's, which was 1, over my change in my x's, which was 2. Looking at this next table right here, we again know that slope is the change of y over change of x. Now I'm going to put a little m here so you remember that that's my slope. M is my slope. All right, so let's look at my y's. 0 to -3. I subtracted 3. -3 to -6. I subtracted 3. -6 to -9. I subtracted 3, so my change in my y is -3. For my x's, to go from 7 to 11, I added 4. To go from 11 to 15, I added 4. To go from 15 to 9, exactly, I added 4. So here, my slope was -3/4. Remember, remember, remember. Always leave as a fraction. Now with this table, we can do this constant change of my y over my change in my x, but what happens if Ms. Singletary gives us 2 ordered pairs? So here, I have an ordered pair, 0, 4, and I have another ordered pair, 6, 12. Just 2 ordered pairs out of a table. We can look at this as, this is my first set of ordered pairs, so it's x1, y1. Why x1, y1? It's the first ordered pair. The second ordered pair we call x2, y2. Why? He's my second ordered pair. With that, we have a formula. Our formula that you have to memorize. The formula tells me that my slope equals the change or the difference in my y's over the change or the difference in my x's. Okay, so now my slope equals, so I have y2, which is 12, minus y1, which is 4, that difference, x2, which is 6, minus x1, which is 0. So now I'm going to simplify. And of course, like any other thing, we are going to reduce and be in lowest terms, but it stays a fraction. So my slope is 4/3. You will use the slope between 2 points a bazillion times. So we're just going to talk about graphs and types of slope for a second. And then we're going to do some practice. The first graph, our first type of slope that we talked about earlier, was a positive slope. With a positive slope, the type of line, as I've said, it's always going to be a diagonal. It's going to come up from the bottom to the top. A positive slope would have an x and a y in the equation. That means I would have y equals 2x plus 1. 2's a positive number. It's a positive slope. It's a diagonal because there's an x and a y in my equation. So I can look at the graph and tell you that. The second type of slope we talked about was a negative slope. Again, I'm going to have a diagonal line from the left side of my graph down to the right side of my graph. With this again in my equation, I will have an x and a y in my equation. So whenever I have an x and y in my equation, I'm going to have a diagonal line. With that as well, I have an x and a y, and I have a negative 2. A negative slope makes a diagonal that goes in the negative direction. The next type of slope we have is something called a zero slope. Oops, sorry, my pen didn't write. Zero. Sorry, my pen didn't write there. Sorry, zero slope. Now, this is where we get a little bit of craziness. He's going to make a horizontal line. Well, think about this. Horizontal, sorry, I got to spell here. Horizontal line. A horizontal line looks like this. With that, I can walk across a horizontal line. It's like the floor. That's what a horizontal line is. It's the floor. It has a slope of 0. All floors should have a slope of 0, or pens would roll across them. To remember this, we have a little acronym called HOI, which you're going to see throughout this unit a bazillion times. The HOI stands for a horizontal line, has a 0 slope, and it's going to be a y equals equation. We talked about this the other day when we were making that chart. If I have an equation that y is 2, it just goes through 2 on the y-axis, and it ends up being a horizontal line. That's a y equals equation. The last type, of slope that you will see is one called an undefined slope. With that, he is my vertical line. Why is he undefined? With a vertical line like this, we're not Spider-Man. If I tried to climb this vertical line, oh no, I would be undefinable on the ground. So therefore, a vertical line has an undefined slope. I would fall off the building and be mush. So therefore, it can't have a slope because it has no bend, no curvature. We identify this with something we call VUX. With VUX, let's move this over just a little bit. It's a vertical line. That's the V. Undefined slope. And it's going to be an x equals equation. If you remember from our homework the other night, we had the table of just the x's. If this was a 3, that would be x equals 3 for my equation. And we'll talk about that a lot this unit too. Today we're just kind of focusing on what slopes look like. So now we're going to go ahead and look at some different pictures first and see if we can come up with their slope, which is just like the first part of your homework. So I'm trying to move to the second page, sorry. Oops. There we go. All right. So just like the first part of your homework, we're going to be given a graph, and it's going to say, hey, determine this slope. As we know, we said that slope equals my change in my y over my change in my x. My y goes up and down. So from the first point, how many did I go up? Well, I went up 1, 2, 3, 4 in the positive direction. Then my change of x says I'm going to run across the page and go horizontally. So how far did I go? 1, 2, 3, 4, 5 in the positive direction, because this is the positive direction of my x value. So therefore my slope is 4/5. 4/5. Now, I'm only going to show you on this one because I'm going to calculate them all the same way each time. But let's just say that I went down this way and then I went over this way. Would my slope be different? No. If I went that way for my slope, I went down, so that's a -4. I went then to the left, that's a -5. It still simplifies to positive 4/5. So it doesn't matter which way you count the slope, you still get the same answer. So you can count it down and over or up and over. My only point is, make sure you go up or down first because that's your numerator. Oops, sorry. All right, next one here. Then I'm going to let you try a couple on your own. So here I want to count my slope. I know that the slope is my y over my x. So what did I do with my y? This one I'm going to go up 2. I'm going to go over 2 to the right. So my slope is going to reduce to the whole number 1. That's okay. 1 is still a fraction. It's a whole number is still a fraction. Okay, pause the video and you try C. All right, let's work it together. So slope went up 4. Left 3 is negative. So my slope is 4 over -3 or -4/3. -1/3. Okay, this is the funny one. I can walk across him, so what's my slope? Exactly right. My slope is 0 because I can walk across a floor. Remember, he's my hoy. Horizontal line, 0 slope, y equals equation. And just to refresh that, when we're writing equations next unit, he's coming through -2, he'd be y equals -2. Easiest equation to write. Uh-oh. Oh no! That means I have no slope. No slope is called undefined. Because again, you are undefinable if you fall. Again, he is my vux, which is my vertical line. Undefined slope, x equals equation. So x comes through 2, so the equation of this line would be x equals 2. Simple, simple, simple. All of that is the second part of your notes on your homework. It all is just like this. You're going to count slope off of a grid. The last part of your homework is going to be, given these 2 points, can we calculate slope? All right, so let's practice. First of all, this equation here you have to memorize. It is not an equation on any formula sheet for the SOL test. You have to know it by heart. So, just to recap, we know that this is x1, y1, this is x2, y2. So now when I calculate my slope, it's going to be y2 minus y1 over x2 minus x1. So y2 is -10 minus y1, which is -5. Denominator, 7 minus 2. So I'm going to put underneath here instead of off to the side. And I'm going to have -10 minus -5 is negative 5. 7 minus 2 is going to be positive 5. So I have negative 5 over positive 5, so it equals negative 1. We always, always, always simplify our answers. Okay, on number 2. All right. So slope equals. Do I have to write the formula? No. But do I have to apply it correctly? Yes. So now I have negative 5. 9 minus 7 is 2. Do I change it to a decimal? No, 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 no. I just leave it as negative 5 over 2. Okay, let's try number 3. Difference in my y's, difference in my x's. If I try to divide this on my calculator, what do I get? You're right, it says error. That's because I can't, on this problem, I can't divide by 0. This is what my undefined slope looks like. And yes, you have to write the word undefined. That's how the SOL test is going to present it. That's how we're going to present it. You cannot leave it negative 6 over 0. But a good way to remember he's the undefined slope, if I'm going to divide it on my calculator, it cannot divide. There's an error. I can't do it. All right, let's do number 4. Notice how I put m each time I'm doing my slope. So negative 6 plus 3 is 9. Negative 2 minus 7 is going to be negative 9, and I'm going to simplify. Okay, number 5. My slope equals, exactly, change in my y over change in my x. Uh-oh, I have 8 divided by 0. So what is 8 divided by 0? If I do it on my calculator, I get 0. Yes, it has to be simplified to 0, or yes, it is wrong. And last but not least, my slope, change in my y's, change in my x's. Simplify. 100%. On your homework tonight, you need to read the directions. The first part of the homework's just asking you, is my slope going to be positive or negative or 0 or undefined? It's the words. Second part, you're going to count the slope just like we did on our examples here. And the third part, you're going to use the 2 points and use the formula to solve your work. Have a great day.